All right, thanks for coming out. My name is Jeremy Mikola. I work at MongoDB, so this is that little company right there. And my coworker series giving a presentation on that tomorrow, but I want to talk a little bit about PHP, specifically what Facebook has been doing in the last year. And at MongoDB, one of my roles there is working on the drivers. So there's quite a lot of PHP development, which in the context of PHP drivers happens to be writing a bit of C and stuff. And then that was basically how I get started working with HHVM, looking at it because there is no driver for it. And so that was a research project we did over last year. And so before I get into describing what HHVM and more specifically hack is, there basically one is a runtime, one is kind of an extension for the PHP language. I'm going to take a little history lesson. And the resolution on this screen is a lot larger than my laptop, so some of the things are a little spaced out. But back in 2008, so hopefully everyone is familiar with Facebook's kind of notorious for being implemented on PHP since from the early days. And even now they have a whole bunch of auxiliary services, but PHP is a large part of their stack. And so 2008, if we go back maybe half a decade ago when their scale problems really started getting large, they needed ways to make their existing code base run a lot faster. And so one of the developers at the company, I don't know if it was a free time project, but came up with an idea of let's compile PHP code into C++. And this is, we have all this legacy code, we can't expend the effort to actually rewrite it in something in a more performant language. But we can get a lot of more performance out of it by just running it in native machine code. And so this they called the hip-hop compiler, so the HPHP C for compiler. And then there were some developer tools around that. There was an interpreter, which basically they were able to just run PHP locally in their dev environments, and then an interactive debugger. And one of the issues with this was that the interpreter and the actual C++ compiler were really two very separate projects. So there was a deviation in terms of developing one versus the other. They had to kind of maintain feature parity. But the gains here versus PHP at the time in 2008, and I guess that was around like PHP 5.2 or 5.1, there was like about a 6 times performance gain. So that was a pretty big win, and this got better as they continued the project. Additionally, these binaries that they were pushing out were basically 1 gigabyte C++ binaries to run on their front-end web servers. So that's kind of something that long-term wouldn't work very well. But in 2010 is when they finally decided to open source the project. And around the same time, we're realizing that maybe down the line, this converting stuff to C++ code is not going to last very long. We need to come up with a better solution. They started investing their development time to come up with a virtual machine to run PHP. And so similar to the hip-hop compiler, took the PHP code and converted it into a syntax tree, but instead of dumping it into C++ code to compile, they generated bytecode for it. And they were able to come up with a virtual machine to run this inside of a JIT environment. So basically, we'll take the bytecode, and in a JIT environment, we'll turn it into native code, and depending on the different code paths, we'll alter the native code a bit. But we're not creating a static C++ program. And the goal with HHVM over HPHPC was, with the compiler, there was a limited subset of PHP. But with the new virtual machine, they were kind of targeting, we want to be able to run everything that a regular PHP interpreter can run. And so in 2011, about a year after this, they finally decided to open source HHVM. And it still didn't get, even though it was public, it really didn't solicit a lot of outside contributions. But around this time, they also started deprecating internally, knowing that we're going to eventually move over wholesale to virtual machines, so we're going to stop using HPHP, C, and I. So they gave up using the interpreter for development, and this is internally in the company, they started using HHVM. And 2012 was an important point because that's when the virtual machine performance started to eclipse the C++ compiler, and which takes us to last year, where they decided that the performance was good enough that we can just really replace the old hip-hop compiler in production. And then anticipating that we might want to get other people to start using HHVM in the future, they added support for things like fast CGI, which is just a way for any web server, usually nowadays it would be Nginx, to just call off to a PHP app server to render stuff. So implementing the same protocols that regular PHP implements. And then one of the other interesting things for respect to the community is Travis CI, which is a great testing service to run unit tests and things based on a lot of GitHub projects mostly. They added support for running test suites in HHVM. So this was a meteoric rise in the community getting more involved in the project as well. And this was around the first time they had a parity lockdown, a performance lockdown, where the Facebook developers would spend basically 3 weeks, no shaving, they'd all and grown up a number of beards, and just lock down on specific features to either boost the performance of HHVM and also the feature parity of supporting, basically measure it by the test suites of popular PHP projects to make sure that they run just as well in HHVM as they do in PHP. And so just in the last couple of months, a few months ago in April, Facebook open sourced the hack language, which I'm going to talk about in the later half of the presentation. But this basically is kind of a superset of PHP, extra syntax that kind of took away some features, added some new things. And that runs inside HHVM. It's not something that you could run on a normal PHP interpreter. And HHVM itself hit a pretty big milestone in version 3. So in addition to hack, they really upgraded the feature parity of the current version of PHP 5.5 to support nearly the same syntax there. And as a result of their lockdowns, they were able to get, they're tracking basically the kind of the top 50 or top 40 PHP frameworks and projects. So things like Drupal and WordPress, PHP frameworks like Symfony and such. And so they were able to get 27 of those, basically their entire test suite working. So that's kind of their measure of how well are we supporting an actual PHP source. And basically their goal for developing future things with HHVM is kind of tracking wherever the Zend PHP implementation goes, which means not only just new features, but sometimes it also means replicating bugs and quirks of PHP, of which there are many. And that's all part of getting existing projects to run the same, and ultimately to make HHVM kind of a drop-in replacement. So talk a little bit about the virtual machine, kind of go through the way the requests work, and basically how it drops into the stack. This is going to be a pretty short compared to the discussion on hack, so I want to focus more on the language stuff. But in 2014, why are we even still bothering with this language? As a PHP developer for a while, I could ask myself this question a number of times. It doesn't have a very good reputation. It's a popular thing that floats around. It's a double-edged hammer. You can still hit nails with it, but it's certainly not as good as a normal handler. So it definitely has its misgivings. But there's some things that are hard to ignore, and it's played a role in, whether for better or worse, whether it made these projects, can't say if it was really the reason for their success or not. But it's pretty hard to ignore that there's some pretty important projects out there that have been developed with PHP, whether it be Wikipedia, which kind of changes the way we learn on an everyday basis. Things like Drupal, which can claim that they power 2% of the websites online. And then Facebook itself, which pulling stats from a presentation they did at Strange Loop last year, they basically have an exorbitant amount of source code to deal with. So Facebook deciding that, we'll just rewrite Facebook in a different language is not really an option when you have so much invested already. At that point, you start looking towards, okay, well, how can we take what we already have and make it run better? That said, and this is pulling from Keith Adams' presentation, the things that he says PHP does get right in his presentation on taking PHP seriously, where he kind of talks about their motivation for investing their development in HHVM. The three things are, one is development workflow. So writing a PHP application, one of the reasons it's so ubiquitous is picking up the language, kind of write your script, refresh your web browser, get immediate results, which leads to a very tight feedback loop. It's possible where all the misgivings of the language, the programmer is able to immediately see the results of whatever they're doing. And additionally, from more of an operational standpoint, every request is kind of isolated, and there is no concurrency to think of. So maybe it's a shortcoming that PHP doesn't really have a good interface for threading and doing these things. But it's also a boon in that it keeps the request and the application code kind of isolated, much easier to debug, and it kind of isolates a lot of unknowns and sandboxes things. So inside HHVM, the lifetime of how it goes through serving PHP code, and there's a big analogy to be had here with what Zend, the main PHP implementation, does. So the bytecode interpreter, there's just 3 flowcharts to look at here. As I mentioned, the first thing HHVM does, takes your PHP source code, converts it into syntax tree, makes it into bytecode. And normally the Zend engine would stop there. And then the bytecode, it's obviously good to put caching as many places as possible. So we obviously want to cache the bytecode if the files on disk haven't changed. So only we'll just execute that. And this is basically an HHVM, if we're running it as just an interpreter and not in a optimized server mode, this is basically the flowchart that it follows as well. When we introduce the JIT, we're taking the bytecode and instead of just executing it once we have the bytecode, we want to check if we have the bytecode converted to some native code. So this is the JIT making the decision, like what is the most optimal machine instructions that I can turn this bytecode into. And one of the benefits of the JIT is that it's going to learn based on as it's a longer running process, it's going to know these are paths of the bytecode that are particularly hot, they get executed more frequently, we're going to take more optimizations for them. And so that's what we consider a hot path, and as we identify these hot paths that should have different flows of bytecode, we'll compile that and then have that kind of cached around just like normal bytecode. If there isn't a hot path, we'll just fall back and execute the bytecode. But the idea here is over a long-running web server, maybe up and serving thousands and thousands of requests, it starts to get a feel of what is the app doing on a regular basis and kind of optimize and anticipate that. And in a production environment, we don't even want to deal with checking if the source code, if we're pushing out the source code, we know it's not going to change until we do new deployment. The bytecode will just pre-compile that. And so it really just comes down to we always have the bytecode available, and we're going to compile it to native code as we identify what the hot paths are. So this is basically what HHVM does in production for Facebook today. And just command that, something you'd run as part of the deployment process to kind of generate the bytecode. So just to look at benchmarking HHVM, and this is based on one example outside of Facebook. It was actually from a few months ago. So this was using a Symfony2 project and using Elasticsearch as a database API, which is just uses an HTTP REST interface. And the bulk of the PHP application here was just converting these JSON responses from Elasticsearch, whereas basically think of it as any other database, but you write and read to it with JSON, and serializing that into PHP objects. So reasonably heavy on the PHP CPU side, and not so much on a little bit of I/O, just talking to Elasticsearch. And the 3 different things they were benchmarking here were an older version of PHP 5.3, which coincidentally stopped being supported last year and is probably still most ubiquitous of all the different PHP installations. And 5.5, which is the latest stable release, which also has probably the least adoption, and that has some benefits, certainly some benefits over 5.3, and benchmarking this, both of those against HHVM. And this was using the fast CGI interface, so it was the first version of HHVM that supported that. And the fellow was using Apache Bench for the load testing. So this is from Christian Stocker at Leap, which is a Swiss web shop. And so they basically did 3 tests. PHP 5.3 wasn't done for everything, but simulating small responses like 7 kilobyte documents from Elasticsearch up to ones that were over 200K. And as PHP 5.5 was about 1.5 times as performant as 5.2. I'm really sorry these slides are so small. But HHVM, as the load got larger, the gains over both versions of PHP became much more apparent. And it kind of culminates with the large responses where we're doing the most processing. So the peak at servicing how many requests per second was about 2x over 5.5 and 3.5 times better performance than PHP 5.3, with half and a third of the response time between 5.5 and 5.3. And so some conclusions just from this particular benchmark was that 5.5 is certainly quite a bit faster than 5.3, and HHVM had several times the gains. But additionally, it really shined. So at the low levels of load, it really was kind of indistinguishable from the actual Zend PHP. But once we added in higher load and just more requests per second and larger CPU, that's where HHVM actually was able to shine, and the benefits of the JIT actually compiling things down to native code become more apparent. And then, so these are the last thing I would say is certainly an argument to just stop using PHP 5.3. But granted that these conclusions are just for this benchmark, and some Facebook blog posts, they've done benchmarking with WordPress and had gains on the order of like 40 and 80 times as more performant as Zend PHP. So things are relative certainly to your application. And HHVM itself is designed with given what Facebook needs to optimize. But one of the interesting things was at the current point in time, Zend PHP did have a better implementation of fast CGI. So that was something that HHVM conceded and said that's something we're going to need to improve. So they definitely had a lock on all the heavy CPU lifting, but ways to go on the API for the network communication with the web server. So as far as getting up and running with HHVM, as far as platform support, you're in luck if you're using Linux. With Mac OS X, there is no JIT, but it's mostly using that as a development environment. So the interpreter mode works, and actual production deployments at Facebook are all using Linux. And Facebook hired, or is contracting with one of the ladies on the PHP internals team, Elizabeth Smith, to work on Windows support, which is kind of something that they brushed over until enough people were asking for it, and now that it's in the public eye, they have to make some efforts to get HHVM working on Windows as well. So in the scope of binaries, which are certainly a preferable way to get HHVM, much better luck with Ubuntu and Debian, and they have other public releases available for other operating systems. But ultimately, in my case, when we were developing a Mongo driver for HHVM, we had to resort to building things from source code. And that was just because right now the packages are available for actually running the server, but in the development headers. We need to grab the source code to compile against. And so there's a fair amount of dependencies. Make-j is definitely your friend here. Without that, it could take hours on a laptop. In either case, this is going to take a while. So unless you really need the development headers, I would stick to the binary packages. I'm not going to talk about how to integrate it with FPM. It's basically in a web server, just changing the socket from wherever your normal PHP FPM process to HHVM. So it was really a one-line change to make it a drop-in replacement, but it is really that simple to swap with the Zend engine. But shifting from HHVM, the runtime, which is probably, I think, the more substantial project, but the thing that is more interesting as a developer, to Hack. And so Hack is, as I hinted at earlier, a set of extensions upon the PHP language. So basically things that if Facebook maybe had more weight or PHP internals was more open to changing things with a quicker turnaround time, these could have been features that were added to the actual PHP language. But instead, it was just easier for them to move at their own pace and just create their own extension. And so Hack is technically a separate language that does cooperate with PHP. It can call into PHP code and vice versa. But it is something that specifically HHVM allows Hack code to have extra type checking and extra language features. And so the most important thing that it offers is static type analysis. So before we approach runtime, we could annotate our code with things like scalar type hints. Basically, all the class method signatures can be typed. And the important clarification here is that it's static type analysis. It's happening before runtime. So the HHVM runtime really doesn't care if we violate. In most cases, it's not going to be strictly enforcing types at runtime as you would expect maybe in C# or Java. But the static type analysis, and I'd say that is particularly important because PHP is still dynamic and it does need to cooperate with that. But static type analysis gives us a way to review all the source code ahead of deployment, kind of like as a, kind of think of it as compile time, and identify what typing errors would be and report those very early into the development process. And that leads to, we have much more meaningful errors about kind of the template that Facebook follows with HHVM. You'll get the actual error and it will tell you what it expected to see and what the reason for the failure was. So every kind of typing error has 3 parts to it. It's going to be very verbose. And addition to the static typing, we have extra language features that people kind of been wanting in PHP for a long time. So we'll look at a few of those. There's been many RFCs to PHP to get things like more type hinting available, because maybe the developers of 10 years ago didn't really care about that stuff, and if we look at like WordPress source code, nobody cared about that stuff. But today, the different frameworks that are being developed today are more kind of modeling themselves after other Java projects or C# projects. And the latest PHP developers, they want these things that they see in other languages, even if there's still a contingent that says they really don't belong there. So Hack adds them, and the nice thing is that they're completely opt-in. We'll see you could have legacy PHP code cooperate with statically typed Hack code and define points where they're allowed to call into each other. And basically all the type analysis and especially removing some of PHP's features, which are actually some of the things in PHP sadness or fractal bad design, removing things like globals or eval or things like variables. Some of the ways to easily shoot yourself in the foot have just been taken out of Hacked. And so that combined with all the static type analysis allows us to catch the bugs earlier and develop faster. And so that is really a huge gain in their developer productivity at Facebook. And I mentioned, just to not brush over it, the type feedback loop, HH client and server. So HHVM itself is the thing that's doing the interpreting and the execution of PHP. The client and server here are basically the static type analysis. So the server would run once, kind of watch a project directory and watch as files get changed. And the client is what is giving you the feedback on type errors and things. And so as the server runs in the background, the client is fast enough to give you that instantaneous feedback if you're they have integrations for things like Emacs and VI where you can get instant feedback if you're typing something, boom, you violated some type checking. You'll get that feedback immediately in your editor. And one of the things Facebook showed in a presentation in April was a kind of an online equivalent, similar to like Atom.io or Sublime Text, an online IDE that works off of HH client with Ajax and just getting, or probably WebSockets, but actually just getting the immediate feedback as you're developing in the browser. Which is a tool that some of the Facebook developers have been using. So that brings us to the first thing to talk about is the different types that Hack brings to the table with PHP. So to give a background, if you're not familiar, in PHP, the type hinting that's available is basically we can type hint against classes that have been defined in arrays. And so anything else, we have no insight into if a scalar value or a primitive is coming into my function. I have no idea what type it is. I can certainly do casting, and that's what a lot of projects currently do, but we don't have actual hinting to say this has to be this certain type. So Hack gives us the thing that there have been countless RFCs for to get type hinting for primitive values. And then it basically extends to be strongly typed all the way down to, even if we're dealing with PHP arrays, say this is an array of, it's not going to be a sloppy PHP array where I could have it store completely disparate items. It's going to be an array of typed elements. This is an array of integers. This is an array of, or if I'm treating the array as a dictionary, another unfortunate PHPism, this is an array where the keys happen to be strings and all the values happen to be integers. And this allows the type checker to, at any point, guarantee that as long as we're in a strict evaluation mode, I know what the types of everything is. I know that I'm not calling, or I'm not passing an argument that's of the inappropriate type. And this leads into, if we're dealing with classes and functions, also annotating what are the values that I'm actually returning. So that's part of being able to validate that contract. Things like nullable and mixed types, certainly, so incoming values, if you want to be null, is an opt-in feature. Otherwise, nulls are expressly disallowed. And if you want to simulate the sloppy behavior of current PHP, there is a mixed type hint for that, which is meant to be used sparingly. But one of the great features here that people have been probably lusting after other languages having is to actually have generics. So similar to generics in Java, or maybe like templates in C++, to be able to define a class, let's say a collection class, and this holds elements of type T, whether that might be a primitive value or it might be a particular object. So this allows a lot more code reuse. I could develop one class that's meant to work with some arbitrary type that'll be, at the time the class is instantiated, we'll know what type it is. And then I can do all my type hinting internally against that, whatever that T type happens to be. So we'll see that when we look at some of the collection classes. But example of what the syntax looks like here, and basically if I took out the before the variables inside the methods here, if I took out the int and I took out the colon and the return type there, this would just be normal PHP code. So Hack lets us basically add in these the type hints all over the place here. And one of the other nifty features, just kind of to cut back on code cruft, is usually in constructors we're taking arguments and we're just setting member properties that we previously declared. So to be able to say, this constructor takes a private int, and I'm just going to immediately saving me the trouble of writing this x equals x. An example of generics. So in my class definition, I'm basically, and this is just using one generic, but in the case if I had like a map collection, it might be T for TK for the key, TV for the value. So we could mix multiple types to form the generic, but basically inside the class scope now I could refer to this pseudo type, which is totally parameterized. And at the time I instantiate an adder, and whatever I pass to the constructor, that's where Hack will infer, okay, this is an adder for this type, whether maybe it's integers or maybe it's a float value. One of the other uses of this is we can have constraints. So we might create generics where we say, it's a generic for type T, but T has to be one of these interfaces. So we can, internally we want to depend on, well, I'm taking something that's comparable, so it's a type of a comparable interface. And then I can make certain assumptions about working with that, that class or that API internally. As we create types, so maybe not in these contrived examples, but if we're creating maybe rich types in an array with a certain mapping of keys to values, we have the ability to do type aliasing similar to a type def in C. And the two things that Hack allows for this are just public type aliasing, which basically the implementation is known all over the place. So with my int, anywhere I would refer to this type alias, I can use the same API or the same primitive operations that I would do on an integer. Whereas in an opaque int, I'm basically not, code outside of wherever that type is defined is not really allowed to assume that it is actually an integer. So this would be useful if you really want to abstract away maybe value objects, or you have IDs in your application where you're, they happen to be integers, but you don't want the other developers to take certain liberties with them and make assumptions. And so the different ways it's enforced is obviously like numeric types can use plus signs. I wouldn't be able to concatenate this as a string because it's a numeric type. Whereas normal PHP wouldn't care, and you just get this loose casting. If I'm trying to use an integer as a string, it'll convert it to whatever it thinks it looks like as a string. Most importantly, all of this is configurable, which really helps when you have a legacy project and you maybe like to take advantage of some of these features. So you'll develop a portion of your application with Hack syntax, and then your legacy application, which you don't have time to port all this over, you just like it to be able to call into untyped PHP code, make use of that, and then have the parts of your application that are in Hack still be enforced strictly. So different modes available. The default one is partial, which allows within the same file, if typing information is available on a method or a class, we'll enforce it within. If not, that's fine. And that's the absence of it and still being okay with that is what allows us to call other PHP code. So this is particularly useful if maybe you're writing a project you want to use Hack for your own service classes, but maybe you're using an existing PHP framework. And so you'd like your Hack classes to use their typing whenever they're working with each other, but you're still relying on some untyped PHP code, basically. And decal is specifically useful if we have legacy code that we want to migrate into Hack. So this is something that Facebook actually developed some tools for. They cover in their documentation. And one of those basically kind of goes through, takes your legacy PHP code, converts it to, tries to connect it with existing Hack code in decal mode, and iteratively attempts to add type hints to things by inferring, well, this is a nullable value, or maybe this is, I see it's being used as a string, so I'll add a string type hint. And attempt to basically run that, make some adjustments, run it against some strict code, and with declaration mode, all we care about is not the body of the method, but just the type information around it. So it's a nice, easy way to start that. If I know this, I don't have time to refactor this entire method, but I know it takes some string arguments and it returns a Boolean, so that's all the information I'm going to provide, and that would be enough to satisfy some strict Hack code to interact with it. So basically it just turns off the validation inside of the legacy code. So depending on which, how aggressive you feel, you can choose a different mode. So one of the main sadnesses of working with PHP is that we have this array type, which is really not an array. It could be used like an array, it could be used like a dictionary, but unfortunately it's just one type that happens to get thrown around and used and abused in all different sorts of ways. So Hack really does away with that and introduces a few things leading up to actual first-class collections. But the first of which I've admired other languages having for quite a while, is just the concept of tuples, which are these fixed length lists with types. So very useful for if you have a function that returns multiple values, maybe like get date and timestamp, or returning a string of the date and an integer. Or to create these pseudo little custom value objects, make a 2D point as just a coordinate pair of two integers. So tuples are a very nice way to represent that, and it makes the, even though this is actually a PHP array underneath, the typing information makes sure that the size and the types therein are immutable. And a counterpart to this, if tuples are these fixed lists, shapes are kind of these fixed structured dictionaries. So alternatively, this is another way that people use arrays, particularly like some really bad PHP ORMs, like to return database queries as giant PHP arrays, which when you're doing relationships, you get an array which might have been one database record, and now you have an embedded array of thousands of other related records. And then your memory limits go off the charts. So with shapes, this is really kind of a similar notion to having structs in C. Or in PHP, in lieu of using arrays, you might just have a class with a bunch of, or an object with a bunch of public properties. So again, useful for small structures, or maybe argument bags or an options array that you want these specific fields to exist. And in this case, kind of just a value object that represents a hit in a web request, where a particular URI gets a certain hit value. And usually you'll end up either with shapes or tuples, you'll probably end up typing them. So you can refer to them by name, just like you would use a type def in C. But the most important feature that allows us to just completely stop using arrays are first-class collection objects. So what Hack brings to the table here, these are really specialized array objects. So the different ways that we use arrays in PHP today. I mentioned using them as actual arrays, where I don't really care about the indexes, it's really just a list of things. Or using them as dictionaries. And in some cases, I want a set of unique elements, which PHP arrays, kind of the ways that we hack around that, are kind of storing the value in the key. So that if the keys were to collide, that there's still only one value there. And pair is just an object-oriented version of a tuple here. The important things about these are these three, excluding pair, which happens to be mutable. Vectors, maps, and set both come in immutable and mutable APIs. So there's two implementations of each. Everything in them is ordered. So as we insert things and we iterate through them, the order is predictable. And we could work with them just like PHP arrays. So the same places that we would use PHP arrays currently in our hack code, we could just start using these classes. Everything works as is. And another nice thing is, and this is kind of where existing solutions in PHP have failed, because there have been PHP libraries that try and make collection classes. But the problem is they're not really integrated into the language. You'd like a literal syntax. I don't want to have to construct and maybe import this class and then construct a vector class. So a literal syntax, so I can just create a vector of elements without actually having to construct a new, creating a new object and calling methods on it. And a familiar API to be able to do things like in PHP, if you look under the array documentation, there's all these array functions do like array map or array filter, array reduce, and these things. Since these are actual objects, instead of having to have these global functions and passing arrays in, we can have these methods like a map and a reduce function directly on the collection objects, which lends itself to a nice fluent API. We can work with callbacks and things like that. So an important reason why of those three, vectors are the thing I'm absolutely most excited with, and this relates back to working with the Mongo driver. In a vector, I can create a vector using the literal right here, and kind of a vector is a generic class. In this case, the type is inferred as integer. And if I were to remove the key for the index 2, which would be removing the element 15, and I were to print these, the keys would still be 0, 1, and 2. But if I did that with kind of the equivalent thing with the PHP array, and I tried to unset the 15, it's the difference between having the vector still having the indexes sequential and a PHP array deciding, oh, the 2 index is gone, Now we're dealing with a dictionary. Congratulations. So in the Mongo driver, and if you're doing things like JSON encoding, this is a pretty big cog in the works here. Because if in my driver, if I'd like to turn a PHP array, the user has a model and it's a embedded collection of other objects, and they happen to delete one that happens to be in the middle. And now when we write that back to the database, if I have to turn that into, I have to decide, well, I'm storing this PHP array, is it going to become an actual array or a map in the database? And the best I can do is I have a function that will go through and look at the keys. If they're all sequential, then we know it's an array. Otherwise, we have to assume it's not. So having an actual vector type is an incredible boon here. And some other features to mention that could be useful. So PHP does have closures. This is kind of what they look like. Not too much different than JavaScript. Unfortunately, they're not real closures. They don't inherit the parent scope. So we have this really ugly use keyword, and we have to import every single variable we'd like to import from the upper scope. So someone back then thought this was a great idea, because why would you want these extra? We don't have register globals as an environment option anymore, so I would want to be explicit about what I'm importing here. And then sadly, in PHP 5.3, even though we have closures, you can't use this. So we usually will have to do that equals this, and then import a that variable if we want to get this inside of a closure. This is all very bad stuff. And so needless to say, this can be a little verbose if we want to have these inline. So maybe it's fine if we're defining a function, but if we want to have pass these around just as callbacks, this is a bit verbose. We'd like shorter syntax. But still, we can do things like composing functions. Closures can return other closures. This is all great and it works. In Hack, Lambda expressions really implement the same interface. So anywhere we could pass a callable, which might be a method, a way to address a method, or an actual closure object, in this case a Lambda object. The most important thing is we get the parent scope immediately, so there's no more use syntax or any of that. And the syntax is quite a lot shorter, so if we're writing these smaller, like a callback API, it's much easier to write something where, so inc is a function that just returns x plus 1, very straightforward syntax. And it's also write associative, so we can have lambdas that return lambdas and define them very easily, like in the second example. One thing to note here is that with lambdas, maybe it's something that they'll implement later, but there is no type checking that comes into play here. But the main benefit, earlier I mentioned, so PHP has these array functions, and where we're dealing with these first-class collection objects, we now have objects to deal with. We can actually call methods. So how much better is it to do what's on the bottom and actually read and make sense of this code than what's going on at the top? And I took some liberties with the spacing. Maybe you can try and fit everything on one line. But basically, I think it's incredibly easier to read what's on the bottom, and the code is certainly more maintainable. And if we were to unset some keys, we wouldn't be left with possibly an object. So a feature beyond lambdas are very similar to, so PHP recently added generators, which other real languages have had for some time now. And in HHVM's case and Hack's case, they developed this kind of before PHP 5.5 finalized on their syntax, so there were some slight differences. But the important things are basically you can yield values out of functions and then pass calling context back into the function or send a value back in. So the important things are there. And this is certainly, I guess it is unfortunate that the syntax is slightly different, but there's ways to work around it if you want to have portable code between 5.5 and Hack. So with continuations, somewhat similar in a concept to having async functions. And so the async functions here are, so one of the libraries that I work with in regular PHP outside of HHVM is called React. And it's very similar to writing like a Node.js application. So you have an event loop, and you could register callbacks on different I/O events and things like that. So in HHVM, Facebook's notion of async functions, their use case was a bit different. They have these controllers. 1 minute, okay. They have these controllers, and they'd like to dispatch a whole bunch of requests out, and then probably towards the end of controller, maybe these are all like database queries that are hitting different points. When they actually need the data, then they'd like to block and wait for these multiple, kind of paralyze all the data requests, and then wait for it at some future point. So they came up with a notion of decorating functions with saying this is an async function, which is really will immediately return this awaitable object, which kind of composes our result. So if you use something like promises, this is similar to a deferred result. It represents the computation that has yet to actually be computed. And so as async functions can call each other, at the very highest level, a function that isn't async will decide to await a waitable result, and that's the point where we decide to actually block until all this happens. So this is a concise example, but a more practical example, and I'm kind of hiding a lot of the, I'll mention it for a reason, but the benefit here is when we are waiting on multiple things at once. That's really where the parallelism comes into play. And unfortunately for Hack, as bad as this is documented in their current documentation, they also don't have any APIs for doing async I/O. So right now it's just you can manually batch and reschedule things. So they have examples for doing like coalesced fetching examples. But one of the things they will be adding is functions to do async database queries. Okay. And some of the additional features, we have user attributes, which are kind of like annotations. Trait requirements, you can kind of like mix-ins, but only usable maybe for certain classes. You can say this trait depends on the class that uses me implementing an interface. Override attribute is basically saying this method, I want to make sure that I'm overriding something. So this is kind of protection that someone hasn't refactored a parent class, and now your child has a method that's no longer called anywhere. Variadic arguments is kind of having a variable args like we have in C, and also a template language, which probably no one outside of Facebook would want to use because it's XML. And to wrap things up on extending HHVM, we have a few options. One is writing things in pure PHP. The second is using native interface, which I'll cover on the next slide, and then third-party extensions, which are usually the native interface. So a main benefit here over normal Zend PHP is we don't have to write everything in C code and compile it and load it as a SO file. We can, if we have something like one of the great examples is the Redis driver, can be completely implemented in PHP. And it's very easy to hook that up as an extension and have that available on every request, just like a standard PHP extension, without having to maintain all the C code. But one of the things we did with the Mongo drive as a research project was taking our C driver and kind of binding it to HHVM. And so we had these PHP code, and we used native happens to be a user attribute, so just an annotation, and that says, well, this function should be used as we should look for a C++ implementation, which happens to be in a corresponding C++ file, implements the same signature one-to-one type mapping, and we can call out the C++ code and go back into PHP code as necessary. So this is a huge game changer in terms of writing extensions. It's also quite undocumented, and I think I'm reaching a time limit here. Some things to look ahead. PHP is certainly iterating a lot quicker than it has been, and having multiple runtimes is a benefit here, as other languages have benefited from. So we don't have a spec for the language. So having multiple ways to test out syntax really helps both projects. And then having alternate features, people will push for more enhancements to the language by seeing it in other projects. And the fact that Facebook is working on HHVM hasn't changed their activity with HHVM core. I'll be willing to stick around for any questions, but thank you for the time, and hope you enjoy the rest of the day.